State the reason why the relation r equal to a comma b such that a less than or equal to b square is not reflexive. Let us take an example a as 1 by 2. For reflexive, we have to check a less than or equal to a square. Since we are going to prove it is not reflexive, we should take an example and substitute in the given relation. So when I substitute half less than or equal to half whole square, which is not true because 1 by 2 whole square is 1 by 4. So it is not true. Therefore, 1 by 2 comma 1 by 2 does not belong to R. Since a comma a form does not belong to R, it is not reflexive. Question number 2. If A is a square matrix of order 3, 2A determinant is equal to K determinant A. Find the value of K. The basic formula is K is multiplied with the matrix A, and if you take the whole determinant, it is K power n determinant A, where n is the order. In this given question, we have 2A matrix and there is a whole determinant. So this 2 will come outside as 2 power n and then determinant A. Since the given order is 3 here, we can take n as 3. So 2 cube determinant A, and that gives us 8 determinant A. So the value of K is 8. If A and B are two non-zero vectors such that mod A cross B is equal to A dot B, find the angle between A and B. A cross B, the formula is mod A vector mod B vector sin theta n cap, and mod A cross B, we should write vector symbol here, mod A cross B is again the same mod A vector mod B vector sin theta. That n cap will not come because when you are taking mod, n cap is a unit vector, so it will become 1. Then the formula for A vector dot B vector is mod A vector mod B vector cos theta. So when I substitute in the question, they have given mod A cross B equal to A dot B. So use the formula for mod A cross B, we can put mod A mod B sin theta equal to mod A mod B cos theta. After cancelling A and B on both the sides, we left with sin theta equal to cos theta, which implies that theta is equal to pi by 4. If star is a binary operation on the set R, A star B equal to A plus B minus 2, find the identity element for the binary operation star. Identity element, we have a definition A star E equal to E star A equal to A. If I take the first part, only this and this, A star E equal to A is the definition. In the question they have given A star B is equal to A plus B minus 2. So if I use it here, it is going to be A plus E minus 2 equal to A. After cancelling A on both the sides, we get E is equal to 2. In the same way, if I take the other two, that is E star A equal to A, if I use the definition, here it is going to be E plus A minus 2 equal to A. After cancelling A on both the sides, we get E is equal to 2, and this belongs to the given set R. Therefore, identity exists, and the identity element is E is equal to 2. Simplify cot inverse 1 by root x square minus 1. In this expression, we have x square minus 1. So it will be better if you take x as either secant theta or cosecant theta. I'll go for secant theta. So when I take x as secant theta, the whole expression will become cot inverse of 1 by root of secant square theta minus 1, and which is nothing but 1 by tan square theta. Since root is there, it will become tan theta. So again, this is going to be cot inverse of cot theta. After cancelling cot inverse and cot, we left with theta. Taking what is theta from this, it is going to be secant inverse x. Prove that the diagonal elements of a skew symmetric matrix are all zeros. Skew symmetric matrix A dash is equal to minus A, or Aij equal to minus Aji. We are going to use this expression. Since it is a skew symmetric, after the transpose it will be negative times. That's why it is Aij equal to minus Aji. They have given about the diagonal elements. For diagonal elements, both I and j are equal. That is, if you have A11, A12, A13, and the next row is A21, A22, A23, then A31, A32, A33. So we see all the diagonal elements have I and j equal. So I am going to take I equal to j here. So going to replace all the j as I. So Aii equal to minus Aii I will get. That means 2Aii equal to 0. That implies Aii equal to 0. It means A11 is 0, A22 is 0, and A33 is also 0. That shows that all elements are 0 in a skew symmetric matrix. If y is equal to tan inverse 5x by 1 minus 6x square, prove that dy by dx equal to 2 by 1 plus 4x square plus 3 by 1 plus 9x square. Since we have 2, 3, 4x, 9x square, all those, before finding dy by dx, this expression should be written in a form so that we get this dy by dx answer. So I will take y is equal to tan inverse of this 5x can be written as 2x plus 3x whole divided by 1 minus 6x square is 2x into 3x. We have a basic formula, tan inverse of x plus tan inverse y is tan inverse x plus y by 1 minus xy. So when I already have x plus y by 1 minus xy, I can write it as tan inverse x plus tan inverse y. In the same way, this can be written as tan inverse 2x plus tan inverse 3x. Now I am going to do differentiation. So dy by dx will be tan inverse 2x is 1 by 1 plus x square, but we have 2x here. So 2x whole square. Using the chain rule, this 2x should be differentiated. So that will give us 2 plus 1 by 1 plus 3x whole square into 3. After simplification, we get 2 by 1 plus 4x square plus 3 by 1 plus 9x square. If x changes from 4 to 4.01, then find the approximate change in log x. I'll take y is equal to log x. Since I want change in y, basically they want delta y equal to how much? That is change in y. So when I differentiate this given expression, delta y is equal to, that is dy equal to log x is 1 by x into dx. The value of x, originally it is 4. So 1 by 4, the value of x is 4 into delta x is change in x. The change in x is 0.1. So the answer is 0.01 by 4 or 1 by 400. Find integration of 1 minus x by 1 plus x square whole square into e power x. This is of the form integral e power x f of x plus f dash of x into dx. And the answer for this is e power x f of x plus c. But this form is not visible directly. So we have to rearrange and bring it to this form and use the formula. For that, I am going to expand the numerator. After expansion, it is 1 minus x whole square. So 1 square plus x square minus 2x. Then denominator, I am just going to put the whole square but not expanding. and we have e power x dx. I'm going to group and individually divide. Grouping in the sense, this alone I'm going to divide by the denominator. So what will happen? It will be integral 1 plus x square by 1 plus x square whole square minus 2x by 1 plus x square whole square, and we have e power x dx. We can cancel this and power, so we left with 1 by 1 plus x square minus 2 by 1 plus x square whole square into e power x dx. If I take the first part as f of x, that is 1 by 1 plus x square, after differentiating this, we get minus 2x by 1 plus x square whole square. You can use u by v method or you can use the direct differentiation. So we identified it is of this form, and if I use this form, our answer is going to be e power x into 1 by 1 plus x square plus c. Obtain the differential equation of the family of circles passing through the points a comma 0 and minus a comma 0. We have an equation of the circle, general equation, which is x minus h whole square plus y minus k whole square equal to r square. But in this case, they have given two passing through point. So if I take a diagram, suppose this is x-axis and y-axis, the circle passing through a comma 0 and minus a comma 0. So this is a comma 0 and minus a comma 0 is here. If you take a circle, it will pass through like this, and we have a diagram something like this. At the same time, I can also have the family of circles. It will pass through these 2 points. Okay. And I can also have another circle like this. It will pass through these 2 points and we get a circle like this. So in every case, we can notice that the center is always lying on the y-axis. So generally, the point C, which is the center, will be 0 comma b. Okay, even it can be in the below the x-axis also, but still I can take 0 comma b. If it is below, b will be negative. And now I'm going to join one particular center with this point. Okay, and suppose if I complete this right angle triangle, this is going to be radius r and this length is a, because it is from the origin. And suppose if I take this as b, then using the right angle triangle, we get r square equal to a square plus b square. Okay, now coming to the general equation of the circle, we already wrote x minus h whole square plus y minus k whole square is equal to r square. So in this, I am going to substitute the center as 0 comma b and radius as a square plus b square. So now we have the equation of the circle, which is x minus 0 whole square, center is h comma k. So for h and k, I am using 0 comma b plus y minus b whole square equal to a square plus b square. Let's simplify this. X square plus y square plus b square minus 2by equal to a square plus b square. You can cancel b square and we left out with the x square plus y square minus 2by equal to a square. We need differential equation of the family of circles. So we have to find the first derivative, which is nothing but 2x plus 2y into dy by dx minus 2b into dy by dx equal to 0. So from this, let us take what is 2b and I'll substitute in this equation. I'll name this as first equation, this is second equation. From second equation, we can get 2x plus 2y y dash equal to 2b y dash. And if I bring y down, so 2x plus 2y y dash whole divided by y dash will be 2b. This we will substitute in place of 2b in the first equation here. So we get x square plus y square minus open bracket 2x plus 2y y dash whole divided by y dash into y equal to a square. Let's simplify this further. We'll take LCM. LCM is y square, sorry, y dash. So x square y dash plus y square y dash minus 2xy plus 2y square y dash equal to a square. This is y square. Now we can simplify, sorry, there is a minus sign, so even this is minus. Now we can simplify these two terms. So x square y dash plus y square y dash, that is minus y square y dash, because y square y dash minus 2y square y dash is minus here, minus 2xy equal to a square y dash. So we can take all the y dash term to one side and take it common. We get x square minus y square minus a square equal to 2xy. This is the required equation. So we have an answer also here, x square minus y square minus a square into dy by dx minus 2xy equal to 0. If mod a plus b is equal to 60, mod a minus b is equal to 40, mod a equal to 22, find mod b. I'll take the square of the first expression, that is a vector plus b vector whole square is equal to 3600. If we expand this, it is going to be mod a square plus mod b square plus 2 a vector dot b vector equal to 3600. Let us take this as the first equation. In the same way, if I expand the second one by squaring, I will get mod a square plus mod b square minus 2a dot b equal to 40 square is 1600. This is the second equation. I am going to add. These two terms will get cancelled. I will get 2 times of mod a square plus mod b square equal to, after adding this, we get 5200. After dividing by 2 on both the sides, mod a square plus mod b square is equal to 2600. And mod a value is given as 22 here. So 22 whole square, which is 484, plus mod b square equal to 2600. So mod b square value is 2600 minus 484. After subtraction, we get, this is 4 1 1 2 2 1 1 6. So mod b square is 2116. By taking the square root, we get 46. P of A equal to 2 by 5, P of B is equal to 1 by 3, P of A intersection B is equal to 1 by 5. Find P of A bar by B bar. The formula for P of A bar by B bar is P of A bar intersection B bar whole divided by P of B bar. Again, this can be written as P of A union B whole bar whole divided by P of B bar. Once again, this can be written as P of, that is 1 minus P of A union B whole divided by 1 minus P of B. Now I have to find what is A union B. Use the basic addition theorem of probability, that is P of A union B equal to P of A plus P of B minus P of A intersection B. P of A given in the question 2 by 5 plus 1 by 3 minus 1 by 5. So group these two first, that is going to be 1 by 5. So we left with only 1 by 5 plus 1 by 3. After taking LCM, we get 8 by 15. So this value we have to substitute in the numerator, which is 1 minus 8 by 15 whole divided by 1 minus P of B is 1 by 3. So 1 by 3. So the answer is 7 by 15 whole divided by 2 by 3. So 7 by 15 into 3 by 2. So after cancelling this, we get an answer as 7 by 10. If matrix A is 1 minus 2, 2, 1, using A inverse, solve the equation. We have a shortcut method for finding A inverse for a 2 by 2 matrix. Suppose the matrix A is A, B, C, D. If I want to find A inverse, take the determinant value 1 by, what is the determinant value for this matrix? AD minus BC. So that will come here, AD minus BC. Then open a matrix, these two diagonal elements you interchange, and the other two elements just change the sign. This is the shortcut method. So using this, if I find A inverse, 1 by the determinant value is 1 minus of minus 4, that is basically 1 by 5. Then these two elements I have to interchange. After interchanging, it is 1 and 2. These two elements I have to change the sign. Here already minus, I will put plus. Here it is plus, I will put minus. So the A inverse value itself 1 by 5, matrix 1 2 minus 2 1. Now using this inverse, we have to solve the given equation. So let us write the equation, that is x minus 2y equal to minus 1 and 2x plus y equal to 2, one below the other. This system of equation I am going to write as a matrix product, which is 1 minus 2, 2, 1 and into xy, that gives minus 1, 2. Okay, this is of the form Ax equal to B. Since I want x, that is A inverse into B. We already got A inverse here. So x is equal to, instead of that A inverse, I can use a inverse matrix 1 2 minus 2 1, and B is nothing but the constant on the other side, minus 1 and 2. Using the multiplication rule, we will multiply this with corresponding column. By doing so, we get 1 by 5, matrix open, minus 1 plus 4, then the next one will be 2 plus 2. Totally, I am getting 1 by 5 and the matrix is 3 and 4. After dividing individually, we get x is equal to 3 by 5 and y is equal to 4 by 5. Discuss the differentiability of the given function 2x minus 1 less than, that is x is less than half, and 3 minus 6x when x is greater than or equal to half at x is equal to half. Take a number line, put half here. Before this it is half minus h, that is slightly less than half, and after this it is half plus h, which is slightly greater than half. Now to find the left hand derivative, I am going to use these two, that is f of f dash of x equal to f of 1 by 2 minus f of 1 by 2 minus h whole divided by h and limit h tending to 0. This is left hand derivative. In the same way, if I write the right hand derivative, I have to use these two, which is on the right side, and that is nothing but f dash of x is equal to f of half plus h minus f of half whole divided by h and limit h tending to 0. If these two values come same, that is left hand derivative and the right hand derivative are same, then it is differentiable at x is equal to 1 by 2. Now let's do the left hand derivative. In left hand derivative, for f of 1 by 2, I should use the second function because there only we have, it is also greater than or equal to 1 by 2. So this is going to be 3 minus 6. Instead of x, I should put 1 by 2. Then minus f of half minus h is less than. So I should use the less than function. Open a bracket, put 2. For x, I have to put this entire function, half minus h. Then minus 1. Then whole divided by h. And we have limit h tending to 0. After simplification, this will become 3. 3 minus 3, 0. So the first term is 0 totally. And here we have minus sign, open bracket. If you multiply the 2 inside, it is going to be 1 minus 2h, then minus 1. And I can cancel these two, whole divided by h. Even these two minus also gets cancelled. I am getting the answer as 2. So we'll keep this as it is. Now coming to the right hand derivative, f of half plus h greater. So I have to use the second function, which is 3 minus 6. In place of x, I should put the whole function value half plus h. This is separate first one, minus f of half. Again the equal to sign is here, so I should go for the same function 3 minus 6, but instead of x I should put 1 by 2 whole divided by h. Here we can multiply the 6 inside, that is 3 minus 3 minus 6h, and this is minus 3, there is a bracket here, so it will become plus 3. Totally minus 3 plus 3 we can cancel, this also we can cancel, whole divided by h. So we left with only, after cancelling h and h, we left with minus 6. These two are not same, that is left hand derivative is not equal to right hand derivative. Therefore, it is not differentiable at x is equal to 1 by 2. For what value of k the given function is continuous at x is equal to minus pi by 6? We will take f of x, limit extending to minus pi by 6 minus. For that, I have to choose the first function because that only not equal to minus pi by 6. This is equal to minus pi by 6. So instead of f of x, I should take the whole function root 3 sin x plus cos x whole divided by x plus pi by 6. and the limit value is extending to minus pi by 6 minus. If I substitute pi by 6, I will get 0 by 0 form. So I have to do some alteration. I'll multiply and divide by 2. So I'll put into 2 and every term I'm dividing by 2, root 3 by 2 sin x plus 1 by 2 cos x in the numerator, and denominator I keep as it is, which is x plus pi by 6, and don't forget the limit extending to minus pi by 6 minus. Now the numerator should be written in the form sin a plus b. For that I have to use the angle values. So this can be written as cos pi by 6, and this 1 by 2 can be written as sin pi by 6. So I'll write it separately here. We have 2 open bracket. This root 3 by 2 can be written as cos pi by 6 into sin x plus sin pi by 6 cos x. Then whole divided by x plus pi by 6. Numerator is of the form sin a cos b plus cos a sin b. So I can substitute that as sin of a plus b, which is x plus pi by 6. After expanding this sin of x plus pi by 6, we get the entire numerator. Now whole divided by x plus pi by 6. When I take x plus pi by 6 as y, suppose y is equal to x plus pi by 6. Now the limit will be changing to y tending to 0. So we get 2 sin y by y, and limit will be changing to 0. This whole value is 1. So the answer is 2. In the same way, if I do the other part, that is f of x limit extending to pi by 6, the other function is, that is limit extending to minus pi by 6, the other function is k. Therefore the k value is 2. In the question already they have given that it is continuous, so I am equating the both the value, I am getting k as 2. If x is equal to a sin pt, y is equal to b cos pt, show the given expression. From x we will find dx by dt. What is dx by dt? The differentiation of a sin pt is a cos pt into p. In the same way, dy by dt if I find, we get minus b sin pt into p. Now divide and get dy by dx, we get minus b sin pt into p whole divided by a cos pt into p. We can cancel these two. Finally, dy by dx is minus b by a tan pt. Now find the second derivative, which is d square y by dx square equal to minus b by a is constant, tan is secant square pt into p. Since it is a chain rule, I have to do dt by dx because we are differentiating with respect to x, and dt by dx the reciprocal of this. So we get minus b by a secant square pt into p into 1 by a cos pt into p. I can cancel this p and p. Rest of the terms we will keep as it is, that is minus b by a square. In the numerator we have secant square pt, and denominator we have cos pt. Actually you can simplify this, but anyway we are going to substitute everything in the LHS. So take LHS. Instead of x, that is a square minus x square, we have as the first term, and a square you write as it is. Instead of x square you take a sin pt. So when I square it, a square sin square pt into y. What is y? That is also the question, which is b cos pt into d square by dx square, just now we found, into minus b by a square into secant square pt whole divided by cos pt, then plus b square. So I have taken the LHS and substituted the values. Now this cos pt I can cancel This will become minus b square by a square. Here a square if I take common, after that I am left with 1 minus sin square pt, which is cos square pt. Then we have into minus b square by a square into secant square pt plus b square. This a square and a square we can cancel, and secant square pt is 1 by cos square pt. So this also gets cancelled. Finally minus b square is left and the last term is plus b square, and that gives 0. So we get the RHS. Find the equation of the normal to the curve 2y is equal to x square, which passes through the point 2, 1. We don't have the point at which the normal is, so we have to assume the point. Let the point be h, k. Now I have to differentiate the given curve. That will give 2 dy by dx equal to 2x. So basically 2 we can cancel, and the dy by dx will be x, and if you use a point h, k, I have to substitute x as h. So I am getting dy by dx as h, which is our slope. Now we have to find the equation of normal. Equation of normal, we have a formula y minus y1 is equal to minus 1 by m into x minus x1. So if I substitute this, y minus y1 is what, k, equal to minus 1 by m is h, just now we found, into x minus h. So I am using the point as h, k, and I got the equation of the normal. So this normal is passes through some point which is given in the question. So this normal is passing through 2, 1. I have to substitute this 2, 1 for x and y, because any passing through points will be substituted for x and y. So substituting 2, 1 in normal, we get 1 minus k is equal to minus 1 by h into 2 minus h. Carry this h to the other side. So h minus kh equal to minus 2 plus h. We can cancel these two, and minus also we can cancel. So kh is equal to 2. Again substituting the h, k in the curve. What do we get? 2k is equal to h square. I'm going to solve these two equations. I'll take this as 1 and 2. We have the value of k from the first equation 2 by h, and k from the second equation, which is h square by 2. Equating both the k, we get 2h equal to h square by 2. So h cube is equal to 4. When h cube is equal to 4, h will become 4 power 1 by 3. 4 can be written as 2 square, so 2 power 2 by 3. If I substitute this in any of the k value, I'll take this first part. So k is equal to 2 by 2 power 2 by 3, that gives us 2 power 1 by 3. So I got the actual point h and k. Substitute that in the equation of the normal, which we have already found. So y minus k, which is 2 power 1 by 3, equal to minus 1 by h, which is 2 power 2 by 3, into x minus h, which is 2 power 2 by 3. And carry this 2 power 2 by 3 to the other side, multiply, we get 2 power 2 by 3 into y minus 2 power 2 by 3 into 2 power 1 by 3. We have to add the power, so it will become 1. So basically it is 2, which is equal to minus x plus 2 power 2 by 3. I can carry the x term to this side. So our answer is x plus 2 power 2 by 3 into y equal to 2 plus 2 power 2 by 3. This is the required equation of the normal. Separate the intervals 0, pi by 2 into subintervals for the given function is strictly increasing or decreasing. F of x is given as sin power 4x plus cos power 4x. We'll find f dash of x. F dash of x is 4 sin cube x into cos x plus 4 cos cube x into minus sin x. 4 sin x and cos x is common, which can be taken out. After taking out, the remaining term is sin square x minus cos square x. I'll take the minus out, and at the same time this 4 is written as 2 into 2. When the minus is out, we get cos square x minus sin square x. Now I am going to apply the formula. 2 sin x cos x is sin 2x and cos square x minus sin square x is cos 2x. So if I apply the formula, it is going to be minus 2. This is sin 2x and this is cos 2x. Once again, we can apply the formula for this entire term. It is going to be minus sin 4x. As per the procedure, f dash of x should be equated to 0 to get the x value. So we get sin 4x equal to 0. Only with the multiples of pi, sin is 0. So this 4x is nothing but n pi. So if I take different values for n is equal to 0, then x will become 0. When n is equal to 1, then x will become pi by 4. When n is equal to 2, then x will become pi by 2. And already in the question they have given the interval 0 to pi by 2. So take a number line 0 to pi by 2 and we have only one value which is pi by 4 in between. Now take a box where the first column is intervals, which first interval is 0 to pi by 4 and the second interval is pi by 4 to pi by 2. And the second column is f dash of x. We have to take minus sin 4x, the one which we equated 0. So including the minus sign I have to take, which is minus sin 4x. And the last column is nothing but the nature, whether it is increasing or decreasing. From the first interval, we will take some value in between, for example pi by 6. Substitute in f dash of x. So f dash of pi by 6, we get minus sin of 4 pi by 6, which is 2 pi by 3. 2 pi by 3 is in the second quadrant and sign is positive and already there is a minus sign, so totally we get negative. So this is strictly decreasing. In the second interval, I can go for pi by 3. If I take f dash of pi by 3, this will be minus sin 4 pi by 3. 4 pi by 3 is, pi by 3 is 60, 60 into 4, 240, which is in the third quadrant and already there is a minus sign and third quadrant sign is negative, totally we get positive. It means in the second interval the function is strictly increasing. A magazine seller has 500 subscribers and collects annual subscription charges of 300 rupees per subscriber. So the total charges will be 300 rupees into 500 subscribers. This will be the total charges. She proposes to increase the annual subscription charges and it believed that for every rupee 1 increase and there is a one subscriber will discontinue. For every increase of rupees 1, one subscriber will discontinue. So what increase will bring the maximum income to her? If you see f of x for this question, the total charges is the f of x and the total charges is always the amount into number of subscribers. Now the amount is going to be increased by some rupees. So I will take it as x. So the new amount is 300 plus x. At the same time, the subscribers, x subscribers will discontinue. So 500 minus x. So this will be the total income. If I expand this, it is going to be 15 with 4 zeros minus 300x plus 500x minus x square. So totally f of x is 15 with 4 zeros plus 200 minus x square. As per the procedure, we have to find f dash of x, which will give us 200 minus x square, and it would equal to 0, sorry, 200 minus 2x equal to 0, we get x is equal to 100. Now find the second derivative, f double dash of x, that will give only minus 2x. Since this is less than 0, we say it is maximum. So when 100 rupee is increased, 100 subscriber will discontinue, but that will give the maximum income. Integral sin x by cos square x plus 1 into cos square x plus 4. Let us take t is equal to cos x. So dt is going to be minus sin x dx. I'm going to replace everything in the integration. So integral minus dt is the numerator, whole divided by t square plus 1 into t square plus 4. For doing the partial fraction, I'll take another substitution, u is equal to t square. But I cannot find du because we don't have t term, we have only t square. So the entire expression minus 1 by u plus 1 into u plus 4. Using the partial fraction rule, the first factor a by u plus 1 equal to, plus b by second factor u plus 4. Now taking LCM, we get a into u plus 4 plus b into u plus 1. On the other side we have minus 1. So this is the expression. Using it, I have to find the value of a and b. Now I'll assume a value u equal to minus 4. If u equal to minus 4, the first term will become 0. So I'll get minus 1 is equal to minus 3b. It means b is equal to 1 by 3. So using the value for u, I can make one term 0 and I can get the value of the other. Similarly, if I use the u value as minus 1, then I get minus 1 is equal to 3a. The second part is 0. So the value of a is minus 1 by 3. After getting a and b, substitute in the partial fraction term to integrate here. So we get integral a value minus 1 by 3 divided by u plus 1, but we have dt. Similarly, plus integral b values 1 by 3 whole divided by u plus 1 dt. Since we have dt, we cannot integrate which is in terms of u, and that has to be replaced in terms of t. We have taken u is equal to t square. So everything will become t square now. So minus 1 by 3 I can take it out. Integral dt by t square plus 1 plus 1 by 3 integral dt by t square. Actually the second is t u plus 4. So here t square plus 4. Now applying the formula, this is of the form 1 by x square plus a square, which is 1 by a tan inverse x by a. So this will become tan inverse t, and here it is 1 by a is 2 tan inverse t by 2 plus c. I will show the formula here. Integral dx by x square plus a square. This is the formula I applied. The formula is 1 by a tan inverse x by a, okay, plus c, and this is the formula I applied here. After that, we have to replace the value of t, which is nothing but t is equal to cos x. So minus 1 by 3 tan inverse cos x plus 1 by 6 tan inverse cos x by 2 plus c. Find the general solution of the differential equation 1 plus tan y into dx minus dy plus 2xy dy equal to 0. First let us divide the entire equation by 1 plus tan y. So we get dx minus dy plus 2x dy whole divided by 1 plus tan y equal to 0. We'll carry dy to the other side. So dx plus 2x dy by 1 plus tan y equal to dy. We have to divide everything again by dy. So we get dx by dy plus 2x by 1 plus tan y equal to 1. This is of the form dx by dy plus px equal to q. By comparing this, we get the value of p is 2 by 1 plus tan y and q is 1. So what is with x is p and the term on the other side is q. After taking p and q, we have to find integrating factor. The formula is e power integral p dy. If I substitute the value of p, e power integral 2 by 1 plus tan y into dy. For integrating this, we have to convert tan into sine and cos. So this is 2 divided by, after converting into sine and cos, after taking LCM, we left with cos y plus sine y, and the LCM part will carry to the numerator. After this, let's add in the numerator sin y and cos y, and before that this 2 cos y can be written as cos y plus cos y, and let's add plus sin y, then we'll put minus sin y, then whole divided by cos y plus sin y into dy. Now we'll group like terms and we individually divide. So if I group cos y plus sin y and divide by denominator, it is going to be 1 plus, and the remaining term cos y minus sin y whole divided by cos y plus sin y dy. We'll split into two integration. E power integral dy is the first one. Okay. Then into e power integral cos y minus sin y whole divided by cos y plus sin y into dy. And the first term is e power y after integration. The second term is e power by taking the denominator as t. T is equal to cos y plus sin y, and dt will be what? Minus sin y plus cos y, which is nothing but the numerator. So the entire term will become e power integral dt by t, which is e power log t. So we get e power y into e power log t, and e and log will get removed, we will be left with only t. So e power y into t, which is nothing but cos y plus sin y. After finding integrating factor, now go for the solution, which is x into integrating factor equal to integral of q into integrating factor into dy plus c. So x into integrating factor is e power y into cos y plus sin y equal to integral q is 1. Again integrating factor is cos y plus sin y into dy plus c. So the final answer is e power y, x into e power y cos y plus sin y equal to integration of causes. We have one more e power y also here. So This entire thing is of the form e power x f of x plus f dash of x. So e power y, and when this is f of x, this is f dash of x. So the answer is only sin y plus c. I'll write the form here clearly. Suppose if you have e power x into f of x plus f dash of x, then this is going to be e power x f of x plus c. In the same way, we have e power y, and here one is f of x, another is f dash of x. So we get the answer. Solve the following differential equation: 1 plus e power x by y into dx plus e power x by y into 1 minus x by y into dy equal to 0. First, let's write this equation in the form of dx by dy equal to the rest of the terms. So for that, this second term should be carried to the other side. So 1 plus e power x by y into dx equal to minus e power x by y into 1 minus x by y into dy. Now dx by dy equal to minus e power x by y into 1 minus x by y whole divided by 1 plus e power x by y. This minus we can take it inside the numerator. So we left with e power x by y into x by y minus 1 whole divided by 1 plus e power x by y. Now this is of the form homogeneous differential equation. So we have to give substitution x is equal to vy. If I differentiate this dx by dy with respect to y, I am differentiating using uv method. So v into 1 plus y into dv by dy. Now I am going to substitute these both in the previous step. That is, instead of dx by dy, I am going to put v plus y into dv by dy equal to e power x by y. Wherever x by y is there, I can substitute as v, because x by y from this is v. So e power v into v minus 1 whole divided by 1 plus e power v. Now carry this v term to the other side. Y into dv by dy equal to e power v into v minus e power v whole divided by, I'm going to take LCM straight away. So minus v minus v e power v. After carrying this term to the other side as minus v, then I'm taking LCM. So we can cancel these two terms. V e power v minus v e power v I cancelled. Then the remaining is y into dv by dy equal to, minus is common in the numerator, e power v plus v whole divided by 1 plus e power v. Now I have to do the variable separable method. So I'll carry 1 plus e power v to this side, into dv is there, and the numerator on the other side will become e power v plus v here, and minus I will keep it on the right side itself into dy by y. Now I have to put integral sign on the both the sides. On the left hand side, if I take the substitution, t is equal to the denominator e power v plus v, then dt will be e power v plus 1, which is in the numerator. So this will become integral dt by t equal to minus integral ty by y. So this is log t equal to minus log y. Since everything is log, I am going to use, instead of the constant c, I am going to put log c. Now if I bring the log y to this side, it will become log t plus log y equal to log c. This will become log of ty equal to log c. We can remove log on the both the sides. So we left with ty equal to c. Replace the t, which is e power v plus v into y equal to the constant c. And v also we should replace, which is nothing but x by y. So e power x by y plus x by y, the whole thing into y equal to c. Prove that a dot b plus c cross a plus 2b plus 3c equal to box product abc. Take LHS. We have A dot, open a bracket. I'm going to do the cross product, that is B cross C, sorry, B cross A plus 2 into B cross B, then plus 3 into B cross C, plus C into A, that is C cross A, plus 2 into C cross B. Then the last term is plus 3 into C cross C. When both the things are same, that is A cross A, B cross B, C cross C, that will be 0. So I am replacing 0 and the rest of the terms I am going to write as it is. That is B cross A as it is. Second term is 0 plus 3 B cross C plus C cross A plus 2 C cross B. And the last term is 0 again. Always try to have the cyclic order. That is AB, BC and CA. This AB I am going to change into this B cross A I am going to change into A cross B by putting minus sign. That is A dot, this is minus A cross B. And this is already in the cyclic order B cross C, so I'll keep it as it is. And this also already in the cyclic order. And the last one is C cross B, so I'll take it as minus 2 B cross C. Now I can simplify the like terms, that is B cross C minus 2 B cross C, that will become A dot minus A cross B, will become plus B cross C plus C cross A. Okay, now I'm going to multiply A with everything, that is A dot minus A cross B plus A dot B cross C plus A dot C cross A. This is a box product, so when two things are same, it is going to be 0. So A comma minus A comma B is the first term. This is A comma B comma C. This is a scalar triple product. Then this is A comma C comma A. The first and the last term is 0. Then we left with only the middle term, which is box product of A, B and C. Find the values of A so that the following lines are skew lines. For a skew lines, the shortest distance is not equal to 0 because they are not going to intersect. We have a shortest distance formula, which is A2 minus A1 dot B1 cross B2, everything is a vector, whole divided by B1 cross B2 within the mod. If this is not equal to 0, then the numerator is not equal to 0. That is A2 minus A1 dot B1 cross B2 should not be equal to 0 because the denominator is a modulus. It will have some value. But if this is not equal to 0, definitely the numerator should not be 0. To use a vector form, I need the vector equation of the line. So line 1, I am going to write the vector form. R vector is equal to I plus 2j plus ak plus lambda times 2i plus 3j plus k plus 4k. This is the vector equation of the first line. And the vector equation of the second line is R vector is equal to 4i plus j plus 0k plus mu times of 5i plus 2j plus k. This entire value is a1 and this entire value is b1 because the vector form is a1 plus lambda b1. In the same way, this entire value is a2 and this entire vector is b2. When I want a2 minus a1, it is nothing but 4i minus I, which is 3i plus j minus a k. So we got the vector equation, that is a2 minus a1 difference. Now coming to this is the scalar triple product which we should use determinant to find the value. In the first row, a2 minus a1 component should come, which is 3, 1 and minus a. In the second and third row, b2 and b1 and b2 should come. In the second row, it is 2, 3 and 4, and the third it is 5, 2 and 1, which is not equal to 0. Let's evaluate this determinant. This is going to be 3 into 3 minus 8 minus 1 into, I am expanding along the row 1. So 2 minus 20 minus a into 4 minus 15, which is not equal to 0. So this is minus 15 first term. Then the second term is plus 18. This is minus 4a plus 15a, not equal to 0. There is a small correction where a2 minus a1 it is minus j. So here we have to substitute minus 1. So when I expand it, it will become plus here. So it is going to be minus 18. So totally we get minus 33 plus 11a not equal to 0. It means a not equal to 3 because 33 by 11 is 3. So a is not equal to 3. A bag contains 4 green and 6 white balls. 2 balls are drawn one by one without replacement. If the second ball drawn is white, what is the probability that the first ball drawn is also white? When we are taking the first ball, there are two chances. Either it can be green or white. I'll take that as E1 first green and E2 as first white. Okay. And let us take A as the second ball we are getting as white, because that is what given here. The second ball is white. So I'm taking the second as white. Now what we have to find is probability of, already we know the second ball is white. So the A will come down, which is already known. And we want to know what is the probability that first ball is also white. The first ball also white is E2. So basically we have to find what is P of E2 by A. Now write formula for this, which is P of E2 into P of A by E2 whole divided by P of, copy the numerator, E2 into P of A by E2. The same thing we have to write in terms of E1, that is P of E1 into P of A by E1. Now P of E2, what do you mean by P of E2? E2 is first white. Getting white from 4 green and 6 white ball is 6 out of 10 into, what is P of A by E2? E2 means white happened already. After that I am getting another white. It means already there will be 9 balls. In that only 5 white will be there. Then whole divided by, copy the same term again, plus coming to P of E1. What is P of E1? E1 is getting first green. Getting first green is, it is 4 out of 10 because we have 4 green and 6 white. So 4 out of 10 into, after getting the green, again we are going to get white, that is P of A by E1 is, after this E1 occurred, that is after green occurred, we are getting the second ball as white. It means already there will be only 9 balls remaining and the white is not already taken before. So all the 6 white will be there. So the getting white out of the total 9 is 6. We can cancel all the denominators, which is 10 into 9. We can also cancel all the 6 in every term. So totally the answer is 5 by 5 plus 4 which is 5 by 9. That is the answer. Two cards are drawn successfully with replacement from well shuffled pack of 52 cards. Find the probability distribution of the number of diamond cards drawn. Also find the mean and the variance of the distribution. Total number of diamonds 13 and the remaining cards are 39. The total is 52. So the probability of getting a diamond is 13 by 52, which is 1 by 4, and probability of the remaining card, that is other than diamond, is 3 by 4. Since we are going to find the probability distribution of the number of diamonds, the number of diamonds can be 0 out of the 2 or 1 out of the 2 or both out of the 2. Let's find the corresponding probability of each. When it is probability of x is equal to 0, which is both are not diamond, it means P of D dash into P of D dash. That gives 3 by 4 into 3 by 4, totally 9 by 16. I'll substitute in the table, which is 9 by 16. Now coming to P of x is equal to 1, it means one success. It means one diamond and other is not diamond. In the same way, it can be in the reverse order also. The first is not diamond and the second is diamond. If I substitute the value, that will give 1 by 4 into 3 by 4, and the second term is also same, so I can put into 2. So totally it is 6 by 16. Don't cancel any term, because if you maintain the same denominator, it is easy for the calculations. Then coming to the P of x is equal to 2, which means both are diamond, P of D into P of D. So we get 1 by 4 into 1 by 4, totally we get 1 by 16. After finishing the distribution table, add all the probability value, check whether you are getting 1. So 9 plus 6 plus 1, totally 16 by 16 is 1. It means the distribution table is correct. We have completed the first part, that is finding the distribution table. Using this, we have to find the mean and variance. For finding the mean, we have a formula E of x, which is sigma xi pi. Multiply the x and p and do the summation. That is 0 into 9 by 16, which is 0, plus 1 into 6 by 16, which is 6 by 16, plus 2 into 6 by 16, which is 2 by 16. Totally 8 by 16, which is 1 by 2. So we got the value of the mean. Then before finding the variance, we have to find what is E of x square. It means we have to square x and multiply with corresponding probability. So 0 square into 9 by 16, which is anyway 0, plus 1 square into 6 by 16, plus 2 square into 1 by 16. Totally we get 6 by 16 plus 4 by 16. It is 10 by 16. We can reduce it as 5 by 8. After this, the variance formula is E of x square minus E of x whole square. E of x square is 5 by 8 minus whole square of E of x is 1 by 4. By taking LCM, we get the LCM as 8, which is 5 minus 2. So we get answer as 3 by 8. The variance is 3 by 8.